So we are doing our chapter network theory. So still we are on our topic introduction to basic components and methodology. So till last class, what we have done? We have done the basic methods. Basic method is what? Star delta, delta star transformation, equivalent resistance method, and the source transformation. And I told you in the last class also that source transformation is one of the powerful technique to analyze the network. So in a brief, I'm repeating the source transformation. In a source transformation, what happened? We convert voltage source into a current source or current source into a voltage source, right? Vice versa. And I told you, if we are converting a current source into a voltage source, in that case complexity will always decrease. Why? First I erase this one. So see, when we convert a current source, a practical current source, always remember, source transformation is not valid in your ideal current or voltage source. So when we convert a practical current source into a voltage source, so in this way, so we have learned that complexity will always decrease. Why? Because you can see number of node is decreasing by 1. If a network contain, for example, a 6 node, now after applying a source transformation, it will contain 6 minus 1, 5. And we also know number of Kvl equation is directly proportional to the number of nodes. How? Number of Kvl equation is equal to n minus 1. So we know if an equation decreases, complexity decreases. So this was a one method to solve the network also. And this is very powerful network. We'll see this source transformation in our upcoming questions also. So tell me, have you have any doubt in the last class? Till last class on any topic? First tell me, because there is a break from the last class. Have anyone have any doubt? Have you revised the topics that we have completed? In the last week, have you revised the topic that we have completed? Good. So today we are going to start our network analysis. Okay, network analysis by 4 methods. Today we are going to start our network analysis by 4 methods, which is, you know the name, mesh analysis, super mesh analysis, nodal analysis, and super node analysis. So in today's class we will try to complete these 4 topics if time permits, and we'll start with our analysis with mesh analysis. So before going into the topic, there is one question for you. Why we use different type of analysis like mesh, super mesh, nodal, super node? Although I told you that any question of a network can be solved using KVL, KCL and Ohm's law. Why we require these analysis? Tell me. Correct. All the analysis, all the theorem that we use in the network, the only purpose is to decrease the complexity. Otherwise, KCL, KVL, Ohm's law are enough to solve any question, but they become so much complex. So in earlier classes, I told you the limitation of KVL. So I'm just reminding you, if a circuit contains a current source and we don't know any voltage around that current source, then we cannot apply the KVL in that loop. Okay? The limitation of KCL we will see further. So first we will start our analysis with the mesh. Analysis. So most of you people know how to apply this analysis, but the important thing is in which question we should apply it. Which question will be easy to apply this analysis, because in a network theorem, one beautiful thing is that one question or an individual question can be solved using different methods. The only question is that complexity. If we are solving a question using mesh or nodal, then from which method it must be the easiest or which require less step. Okay. So all these answers I am going to give in our 4 analysis. First we will start our topic, which is mesh. Okay. First we will start with mesh analysis. So I already told you what do you mean by mesh. The mesh is the innermost loop in a circuit. Means the loop in which there is not any other loop is known as mesh. Okay. For example, I am giving you one circuit. Let's suppose this is example circuit. This is 5 volt, 2 ohm, 3 ohm, 10 volt, 1 ohm, 4 ohm. Now tell me, how many meshes are there? How many meshes are available in this circuit? Tell me quickly. How many meshes are available in this circuit? Good Deepika, good Atul, good Pooja, good Govindish. How many meshes are available? We have 2 meshes here. See, earlier I told you, if I asked how many loops are available here, so you can see 1 loop, 2 loop and 1 outer loop. If I am talking about mesh, it means I am talking about the innermost loop which does not contain any other loop. And in that case, we have only 1 loop, this one. I can say this is loop 1 and this is loop 2, or mesh 1 or mesh 2. Okay. So I am giving you the steps how to solve the question using mesh analysis. Okay. Steps. First step. Count number of mesh. First step. Count number of mesh. How many meshes are available in a circuit? Okay. First step is this. Second, show the direction of current in each mesh. In each mesh, you have to assume the direction of current either clockwise or anti-clockwise. Third, an important step, mark the polarity across each passive load. Mark the polarity across each passive load. And the final, write KVL equation of each mesh. Write KVL equation of each mesh and then solve to find loop current. And solve to find loop current. So see, one important thing happen here. First of all, these are normal steps. First is the count number of mesh, show the direction of current in each mesh, mark the polarity across each passive load, and the KVL equation, then solve it. Now the question arises, how many KVL equations are possible in a circuit? If I am giving you one circuit, then tell me how can we find out number of KVL equation? See, this is a trick question. If I ask you number of KVL equation, then it will be equal to number of loops. If I ask you number of unique or fundamental KVL equation, fundamental KVL equations, then it is equal to number of mesh. Why? See, whenever you see the loop, the KVL equation can be written if there is not any current source present. So in a circuit, I can say this is a loop 1, this is a loop 2, and this is an outer loop. So from the outer loop, I can also write the KVL equation, which means in this circuit, number of KVL equation possible is 3. Okay, but the outer loop is actually made up of combination of first loop and second loop. Similarly, when you write the equation of outer loop, you will see if we add up this KVL equation plus this KVL equation, then you can get a KVL equation of outer loop. That's why when we ask what is the number of unique or fundamental KVL equation possible, then it is equal to number of mesh. Always remember this step. In a question, they can ask in any form, number of KVL or unique or fundamental KVL. Here we are only seeing in mesh analysis, we will only see the unique or fundamental KVL equation because this is actually a mesh analysis. So we only see the mesh, not other loop which contain one or more loop inside it. Okay. So with this number of steps, I will solve this question. Okay. And see, in your practice, whenever you do practice, follow each and every step. Okay, it is must. When you do practice, follow each and every step. In an exam, you can skip the steps, but that confidence can come only in the practice if you follow each step. Okay. Now see. First point. Count number of mesh. So here, I know number of meshes 2. Second, show the direction of current in each mesh. It means number of mesh is equal to number of variable. So here I have 2 mesh. So I am showing the direction of current in each mesh. This is I1, this is I2. This is I1, this is I2. You can show any direction, clockwise, anti-clockwise. What I follow? I take both current in a clockwise direction. You can take any direction. You can take this current as a clockwise, this as an anti-clockwise, or vice versa, or both anti-clockwise. No problem. Next step, this is an important step. Mark the polarity across each passive load. Okay, mark the polarity across each passive load. And in the first lecture, I have told you how to mark the polarity in a sign convention topic. So, I1 see here. I1 is flowing in this direction. It means it is entering 2 ohm in this. It will be plus, it will be minus. Similarly, in 1 ohm, I2 current is flowing in this direction. It will be plus minus, it will be plus minus. Right? Now see the 3 ohm resistor. This is an important thing here. 3 ohm resistor. This is a common branch between loop 1 and loop 2. Okay? So for this, I am giving you some concepts here. Let us suppose I have one branch of RO. I have one branch of RO. Let us suppose. And let us suppose from here the current is I1 flowing. From here the current is I2 flowing. Right? Means you can see in a branch, from this branch I can see 2 currents are flowing. But this cannot be possible. In a branch, only one current in a one direction can be possible, right? So what will happen in this case? So see carefully. See, I1 is flowing. It means I1 is coming in this direction. I1, let's suppose we are coming in clockwise, so I1 is coming in this direction. Or you can see I2 is going in this direction, right? Now, in this case, if the direction are opposite, if direction of both current in a branch are opposite, like this case, you can see direction of both are opposite, then assume any current is greater than other. You can assume anything. Here, I am assume I1 is greater than I2. Okay? But no problem, you can also assume I2 is greater than I1. So here, if I am assuming I1 is greater than I2, it means resultant current is actually flows in a direction of I1. Resultant current actually flow in a direction of I1, and that current is nothing but a difference of both current, I1 minus I2. This will be the resultant current. But the assumption is I1 is greater than I2. But if you change the assumption, for example, I2 is greater than I1. For example, if my assumption is this, assume I2 is greater than I1, then you can see resultant current will flow in a direction of I2. Okay? And that resultant will be I2 minus I1. Okay? Both current are equal. You can take any assumption. There is no any marking or not any compulsion which current you will take the greater. You can take I1 or I2. So this is the first case. If the direction is opposite. Understood? Yes or no? If the direction of current is opposite. Tell me. Okay, good. Now see, if the direction is same in a branch. For example, if a direction is same in a branch, this is R. Let us suppose here it is flowing I1, here it is flowing I2. Okay, you can see in a branch both current direction is same. I1 is actually flowing here. I2 is also flowing in this direction. It means both the current have a same direction. It means the resultant current will also be the same direction, and the resultant current will be nothing but summation of these two current, I1 plus I2. Okay, so these two cases you should remember by taking a common branch in case. Okay, now we will see in our question. Okay, so see here, in this question? I1 and I2 we have already marked the branches which are not common. Now we will see the common branch 3 ohm. In this I can see I1 is coming in this direction and I2 is coming in this direction. Okay, so assume I1 is greater than I2. If I am assuming I1 is greater than I2, then resultant current will flow in this direction, I1 minus I2. And according to the direction of a resultant current, the polarity according to it will be here plus and here will be minus. Right? Now I can write the Kvl equation, which is the next step. Write Kvl equation of each mesh. Okay. So let's suppose I am taking mesh 1, this mesh. Now write Kvl equation. Minus 5 plus 2I1 plus 3 I1 minus I2 equal to 0. This is the Kvl equation of mesh 1. For mesh 2, you can write I2 multiplied by 1 plus 4I2 plus 10. Now see, I am coming in this direction and I am seeing the minus sign here. That's why minus 3 I1 minus I2 equal to 0. So this is the Kvl equation of second mesh. Now next step is to solve the equation. Okay. So we have two variables. So we require two equations and we can easily solve this. Right? Any doubt in this question? Because in every question of mesh analysis you have to use this step. Okay. So tell me if you have any doubt in any step. Good. Okay. So I will give you one question now and then solve it. So students, solve this question. Okay. In this question we have given some elements in a circuit and we have to find out power absorbed by dependent source, this dependent source. So first tell me which dependent source is this? Current dependent voltage source. Correct, Pooja? This is a current dependent voltage source. So try to solve this question quickly. And try to follow each and every step in this question, okay? Don't skip the step if you are practicing the first time. So let's see, solve this question, how to solve this question. So the first step is to count number of mesh. So here I can see number of mesh is equal to 2. Second step is show the direction of current in each mesh, okay? And I told you, you can take clockwise direction or anti-clockwise direction, no problem. Here you can see one current is already given in a question, right? And that current is actually a dependent source magnitude, which means dependent source magnitude depends on the current flowing in this branch, okay? And we also have to take one current here. It means I'm either take I1 like this, I can take I1 like this, but you can see if I'm taking I1 like this, so you can see the direction of I is opposite to I1. And if we are taking in that way, then we are only increase the complexity. So to decrease the complexity, the easiest way is to, if in a current, direction of current is given, if in a question direction of current is given, take that direction as a loop current or a mesh current. For example, in this direction of current is given, right? So what will I do? I will take this current I, same current I in this direction. Okay? Then we will take same current I in this direction. So we are taking I in this direction. Okay? Here you can take any direction. Let us suppose I am taking clockwise, which is I2. Here I have taken I because the same current is flowing. Okay? So to reduce the complexity, here I am giving a tip that if the direction of current is given in a question, take that direction as your reference. Okay? Now see, now we will apply the polarity. If the current I is flowing in this direction, this will be plus minus. Here this will be plus minus, and see carefully here. I is coming this direction and I2 is coming in this direction, right? It means both the current have the same direction. if both the current have same direction in a common branch, what we will do? We add up that current, I plus I2. Now I plus I2 is going in this direction, which means it will be plus, it will be minus. I hope you got this. If you have any doubt in this step, ask me. Now we will write the Kvl equation. See here, you can write Kvl equation in any form. So this is mesh 1, this is mesh 2. For mesh 1, I am going in this direction. Okay, I am going in this direction. It will be plus 2. The current flowing through 2 ohm is I plus I2 plus 3I plus 4, and here this one minus 2I equal to 0. Here one more important point for you. This is a voltage source, right? If this is a voltage source, the magnitude here represents the magnitude of voltage, which means unit of this whole term is nothing but volts, because this is a voltage source. So never take the magnitude of voltage source as the current flowing through it. Okay, this mistake is happened by many students. So carefully see this, that the magnitude of a voltage source is nothing but in a volt, have a magnitude of volt. Okay, remember this point. The unit of magnitude, the unit of the magnitude of a voltage source is in volt. Okay, minus 2I equal to 0. Now I can simplify this equation. This will become 3I plus 4 minus 2I equal to 0. This cancel, become 3I plus 2I2 minus 4. First equation. Okay, now we'll see the second equation. M2. Here you can see the M2. It will be 4I2 plus 3 minus 2I plus 2I plus I2 equal to 0. So 4I2 plus 3 minus 2I plus 2I plus 2I2 equal to 0, right? 2I cancel out. We will become the left is 6I2 equal to minus 3, I2 equal to minus 1 by 2 ampere. So from this loop, directly we can find out the I2, which is the minus 1 by 2 ampere. Now put in 1. So 3I plus 2 minus 1 by 2 equal to minus 4. 3I minus 1 equal to minus 4. It means after solving it, I comes out to be minus 1 ampere. Okay, check the calculation also. I comes out to be minus 1 ampere. So till now we have find out the current in both mesh. But the question is, we have to find out, carefully see, power absorbed by the dependent source. That how much power is absorbing by the dependent source. So here you can see, current I plus I2 is entering at the negative terminal. So tell me, in the circuit diagram, what is happening? Power absorbed or power delivered? What is happening according to the direction of current and this? Tell me. In the circuit, dependent source, power is absorbing or delivering? Power is delivered, because in a first class I told you, if in a negative terminal current is entering, it means power is delivering. So here, according to the network, I can write power delivered is equal to voltage multiply the current passed through it, which is nothing but I plus I2. 2I multiply I plus I2. So power delivered is equal to 2 multiply what is small I is minus 1, multiply minus 1, I2 is what? Minus 1 by 2. So minus 2 multiplied by minus 3 by 2 cancel, we left 3 watt. So what is the power delivered? Power delivered is a 3 watt. But in a question they have asked what is the power absorbed. So the power absorbed is nothing but negative of power delivered, which means minus 3 watt. This is the answer of this question.